All right, so just a quick video going over kind of the intro lesson for quadratics for anyone who wasn't there that day. I think there was a few of you, and then at least one other who missed like most of last week. So I just kind of want to do a quick little video to sort of give you a bit of a hand. So first of all, the definition of a quadratic function is that degree of 2. So it means the highest exponent in the polynomial is a degree of 2. So if we look at the examples that are here, y equals x squared, that's a degree of 2. X squared, or I guess n squared, but same difference, x squared minus 4, highest degree there's 2. X squared minus 4x minus 7, highest degree there is 2, so therefore it is a quadratic. The actual graph of those quadratic functions are called parabolas. And then we kind of looked at, this is what we typically call the origin function. So y equals x squared. It's called the origin function because we're not multiplying by anything else. You are literally just taking your input x and squaring it to figure out what the output is, y. So to do that, all we've done so far for graphing these is a table of values. I haven't taught you any other methods yet for graphing them other than a table of values. So all you do is you take -4 and you plug it in for x. Be sure to use brackets because -4 is being put to the power of 2 in brackets. So that means -4 times -4, which is positive 16. Okay, so just make sure you use brackets whenever you're doing anything for substitution. Anyway, you would have just plugged those all into your calculator or done it in your head, and you would get these numbers. So you'll see here, so -4, we get 16, -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. So notice that after this point, all the y values repeat. When we go to graph that, you'll see 0, 0 is here. And then all of those other points where the y values repeat, we call those symmetrical points. So 0, 0, the point that kind of before they started to repeat again, that's called the vertex. Okay, and the vertex is always your highest or lowest point. The other thing that we talk about is something that's called the axis of symmetry. So the axis of symmetry is kind of the invisible line I could draw down the middle of this parabola. And once I draw that, it would split it into two symmetrical halves. Okay, and you see how if let's say I put a mirror right where this axis of symmetry is, it would show me the exact same thing on either side, right? It would reflect in that mirror the exact same thing because it is symmetrical on either side. One of the other really important things that we talked about these symmetrical points is that I know that my axis of symmetry has to be in the middle of the x values here. So the x value, I'll just use this highest one. So the x value here is 2. The x value here is -2. I know the axis of symmetry has to be in the middle of that. So if you were finding it algebraically, you would just add those two x values together and then divide by 2 because you're basically finding the average, the middle of them. It's 2 points that you added, so you divide by 2. If you're doing it from a graph, you can literally just kind of move in. So like I'd move in one space in either direction and then move in another space and bam, the 2 points, spaces that I've moved in have touched. So that's kind of a way you can do it too. You just sort of move in until they are sort of hovering over the same place. But yeah, it's easier to sort of do it algebraically, in my opinion. So you would just add the two x values from the symmetrical points together and divide by 2, and that's going to tell you where the axis of symmetry is. All right, so your vertex is really, really important. It also separates your symmetrical points. The axis of symmetry is like the line that separates your symmetrical points. And those are one of the key things. So typically we want to find our x-intercept, our y-intercept, and our vertex, sorry, and the axis of symmetry as well, but our x-intercepts, our vertex, and our y-intercept. On this particular graph, they were all in the same place, but it doesn't usually happen. So that's kind of the key thing. So the fact that it's a degree of 2 is what makes it a quadratic. So the degree of 2 is the highest, makes it a quadratic. And then every quadratic is going to have a vertex and an axis of symmetry. Every quadratic will also have a y-intercept, but doesn't always have an x-intercept. So that degree of 2 actually means that there could be two x-intercepts. It means there could be one x-intercept, which we see in this example. There also could be no x-intercept. So that degree of 2 basically tells you the maximum possible x-intercepts, but it could be 2 or less. It just can't be any more than 2 if your degree is 2. So that's kind of important as well. So those are just little tidbits of information that are important. I think what I'll do from here is look at some of the other examples that we did in class, where we talked about the A, B, and C values a little bit too. So they did do an assignment in class, if you weren't here, where they tested out what the A, B, and C values did using a program called Desmos. But just so you know what A, B, and C actually mean, um, A is always the coefficient attached to x squared. B is always the coefficient attached to x, and C is always the constant term with no coefficient. All right, so if you look at the equation that's here, I know I have some stuff written in, sorry. That negative that's in front of x squared means -1. It's like an implied 1. So that means A is -1. 8 is attached to x. There's a positive sign in front of it. So +8 is your B value. If there was a negative sign in front of it, it would be -8 for your B value. And then our C value, the one that has no variable attached, is -7. So C is -7. And like I said in class, they looked at what each of those values do. Really quickly, the A value is what makes the U shape of the parabola wider or skinnier. If the A is a high value, so like 2, 3, 4, whatever, if it's a whole number, basically, that's what makes it skinnier. If it's a fraction, like 1/2 or 1/4, that's what makes it wider. And then if it's positive or negative, the A value, that tells you the direction that it's open. So notice that A is -1 here. That tells you that the parabola is opening down. If A was any positive number, and I should say, sorry, A is -1. If A was any negative number, that just tells you that the direction is opening down. The values that I mentioned before is what tells you if it's skinnier or wider. It's just if it's positive or negative, tells you what direction it's opening. So any negative value is going to result in a parabola that's opening down. Any positive A value, which I'll just scroll really quickly to the next example. Which isn't on there. Okay, I can scroll back to this example. So this has a positive 1A value and it opened up. So that's kind of proof that that's what it does. But again, you could also do the assignment where you test out different values if you really want to know. Your B value, the one that's attached to X, is what shifts it side to side. It's what we call the horizontal shift. And then your C value, the one with no X, is what moves it up or down. It's what we call the vertical shift. And your C value is also your y-intercept. And I explained that today online, so hopefully that made sense. But just again, really quickly, remember your y-intercept is when we make x 0. So the second you make any of these zeros, it's going to kind of eliminate them, leaving you only with the C value. So yeah, all we did for this particular equation is they plugged in these different x values. So they plugged in 1. Again, be careful of your signs because this is like a -1 in front. So when you plug 1 in for x, use brackets. But then order of operations says after you square something, you times it by whatever's attached. So no matter what you plug in, once you square it, you then times it by -1, right? But just follow order of operations. The example I have here right now is for 2. It's all worked out. So notice that anytime I plugged something in, I used brackets. So it was -1 times 2 squared plus 8 times 2 minus 7. 2 squared is 4. Negative 1 times 4 is negative 4. And then 8 times 2 was 16 and minus 7. Negative 4 plus 16 minus 7 is 5. So when I plug 2 in, I get a y value of 5. Okay? Honestly, that is a lot of the basics. So for now, we are just graphing them with table values anyway. So as long as you understand how to plug values in to the equation and solve for y, and as long as you can pick out those key things. So the y-intercept, of course, is where it crosses the y-axis. If you have the equation, it's just the c value. If you're just looking from the graph, then you just see where it crosses the y-axis. So it's crossing the y-axis at negative 7. So we write that as an ordered pair. X is 0 on the y-axis, obviously, so 0 comma negative 7. The x-intercepts are just where it crosses the x-axis and also when y is 0. So it crosses the x-axis at 1 comma 0 and 7 comma 0 here. The equation of the axis of symmetry is the vertical line I could draw. Because it's a vertical line, it's always x equals. And then it is, if I drew it right now, it would cross through at 4, right? So it's x equals 4. It's also always the x value of the vertex. So remember, our vertex is our highest or lowest point, depending on the way the parabola is drawn. In this case, the vertex is 4 comma 9. So my axis of symmetry is x equals 4. Is the vertex a minimum or a maximum? It is a maximum because it is the highest point on that graph. If the graph was opening up, so let's just say we had a parabola that looked like this, then obviously our vertex would be a minimum point because it's the lowest point on that graph. Everything else is increasing after that point. And if it asks you for the value, so if it says, is the vertex a minimum or maximum, and then it says, what's the value? It's asking for the y value in there. So it would ask you for the 9 in that case. So again, our vertex is at 4 comma 9, the vertex here. Your x value in the vertex is the x value for the axis of symmetry, right? If I drew a vertical line going through this, it would cross the x-axis at 4, so it's x equals 4. And then the y value is the value they're looking for when they ask for the min or max. So the vertex itself is the minimum or the maximum. The y value is if they say what's the value of the minimum or maximum. Your domain is x epsilon r because every x value is going to work. It doesn't matter what x value you plug in, you will get a corresponding y value. Because we, literally definition is that we just square it, right? And then maybe we do some other stuff, but there's never going to be a value that you can't plug in here and put it to the power of 2. So every x value will work. So x epsilon r. And then arrows on the end also tell you that too, right? Because this is going to continue on forever and ever and ever, which means even as I increase this way, it's just going to get lower and lower down here. So there will never not be an x value that will work for a quadratic function. For your y value, because we have a minimum or a maximum, there is a restriction to y. So 9 is our highest point. Like I said, it's the maximum value. 9 is our highest point, and everything else is obviously less than that point. So y has to be less than, it can be equal to, but less than equal to 9. And then other than that, every y value will work. So y epsilon r. Again, if we had a quadratic that was opening up, I'll try and pick a nice point here. Let's say it was this. So let's say this was our quadratic. My vertex would be at negative, 1, 2, 3, 4, 5, 6. Negative 6, comma, negative 2. X is always first. So my vertex here would be at negative 6, comma, negative 2. If that was the case, my range, now that's the lowest value, right? So your range would just be y is greater than or equal to negative 2, comma, y epsilon r. And then this would be a minimum, right?